Good evening, students. I'll start with the class. In the previous class, we were solving problems in how to add errors, multiply, divide, what to do. Okay, I'll continue with those problems. We had seen, suppose if anything is p of a square b cube upon c raised to 4. And then if we want to calculate p, this will have a normal p plus or minus your delta p. This is always a error. This p, we normally what we do directly, we use the same formula. If there's a divide, directly a will be given to you, b will be given to you, c will be given to you. So the a direct values, we always put them, and then we calculate your main p. And in terms of delta p, if we have to find, then we always use that this in terms of delta formula, that is delta p upon p. Then this coefficient, we always write them at the side. So delta a upon a, whether it's multiply, still we write it as plus. Then 3 times this power will come now, b upon b. Even if there's a division, still we write it as plus. And then delta c upon c. After this, we calculate, we substitute the values here, then the p we take up, and then we find delta p. And that delta p we substitute here. We solve problems based on this. The question is, length is given to you as radius is given as find volume of a wire. The volume of a wire would be always somewhere in form of a cylindrical form. It's like a long cylinder. Basically, we have to find volume of a cylinder. Does anybody remember from the 10th standard mensuration chapter? What is the volume of a cylinder? I'll send you all in the group of all the areas. Just remind me all the mensuration formulas if you all have forgotten. The volume of a cylinder will always be equal to pi r square L. And then now these are also, r is been given to me, length is also given. What we have to find? Finally, V volume, we have to write it as V plus or minus delta V form. We need this. So this normal V we can always calculate by directly substituting the value. So this is my L, and this is my delta L. And this I know, my R, and this is my delta. This everybody should know by now. This is always the main letter, and this is always delta L. So first we'll find this part, basic normal V. V would be pi r square L. So substitute pi, we will take it as 3.14. R is your normal R we have to take. Here no taking errors. Errors will come in this part. The basic normal values. What answer you are getting? Multiply and tell. 1 square will be anyways 1. So multiply 3.14 into 4. Tell me the answer.
$12.56.
Yes. 12.56. Now what we'll do is, since they have given us specifically the units, no, we have to make a habit of writing the units also of this. So volume will always be, if you just want to check, this will be centimeter square because R is centimeter. This is again centimeter. So 2 plus 1 will always give me centimeter cube. When we know that for volume it's always cube. Okay, 2 times centimeter. So total 3 centimeters is will cube because this is square. Pi doesn't have a this. It's a pure number, no? So that will not have a unit. So we got the first part. Now we have to calculate your delta V. So for delta V, we have to use the next formula by splitting this up. Now over here, while splitting, now this fellow, this is a constant or a fixed value. So there will be no error in 3.14 is a fixed value and it will not have any error. The pure numbers or those constants have to be avoided. Okay, so while calculating, you just have to ignore it. While calculating error, not in this. Here you have to substitute normal. Only while calculating error, you have to ignore it. Ignore the constant. So directly move on to this. So there's a power which will become your coefficient. So delta R upon R. And multiply this, this will be plus. Delta L upon while calculating the error, ignore the constant. Now put all the values. Delta R you know from the question. R also you know. Delta L this also you know. And V you just now got here. Put all the values and calculate your delta V. Delta R 0.01 upon 1 plus 0.04 upon 4. And then this will give you 0.02. Now delta V, this will go up. Or before that also you can just calculate. This will be 0.03 after adding. So
Yes,
delta
answer is 9
9 point 9 point.
40.
I get 9 point. Such a big error, more than the length. Check the decimal points. 4 decimal places you have to shift 2 are here, 2 are here. Right now, just ignore the decimal points. You can ignore the decimal point, just multiply 1, 2, 5, 6 into 3. Okay. So that would give you 0.03 and that is 12.56. Yeah. Now check now how much you're getting. This would be 3 anyways. How many decimal places to be shifted? Total, you have to check. Here there are 2, here there are 2.
Oh.
So total 4. So 1, 2, 3, 4. Point will come here. So your answer is 0.3768. Up till this much also you can write, no problem. The answer is final. Delta V will be equal to 9 point, what was it, 12.56 centimeter cube and plus or minus 0.3768 centimeter. So like this will be your answer. So just be careful while multiplying your decimal points. If you finish this, you can try. Any doubts in this? You can ask. Huh? Suppose if you have a cube has how many faces?
6.
Yeah. So total there will be 6 faces. Total surface area means the outer area of the, suppose if you have a box cartoon, okay, this normal carton, if you want to know the area is the outer area, not what is filled inside. Volume means what is filled inside. Suppose if you fill the box with sand, okay, or with some powder, whatever is inside it would be your volume. But what is the outer area? That is called as a total surface area. So if one of them, so it's like 6 squares, okay, like 6 squares joined together. Your total surface area of cube is 6 times. If this is A, what will be the area of one face? C square, length into breadth. One face is A square. So there are total 6 faces. There's 6 times the A square is the 6 A square is the formula for your cube. So you can use the normal A only, capital A for total surface area. So what we need to find? Error in that. So A, you have to find this final answer. So first find this part and then find this. So first let us find the capital A, that is same formula, 6a square, normal, directly this one, because this is your A and this is your delta A. So 6 into 4 will give you 24. Now A is, just check the unit for area. You know that it is centimeter, because A is centimeter. The whole square will become centimeter square. So unit is 24 centimeter square. So you got your first part. Now you have to calculate delta A. So while calculating delta A, ignore that 6. 6 is a pure number and it will not have an error in it. How much are you getting? Has anyone calculated error? This is to be ignored. This will become 2. Now calculate.
The 4.8.
I'll get big answers, man.
Miss 0.48.
Or you're getting, what is the value I gave you? Check. This all took up and multiplied. So delta A upon A is given to me 24. 2 into 0.04 upon 2. 2 and 2 will cancel. Now check. How much are you getting?
0.96.
Yes. Basic calculations, to always make mistakes, then no point. Huh? Get 0 then. A will be 24 by the units square. This will be on. If a cube has mass 2 grams plus or minus 0.2 gram and volume find percentage error density. Now forget about that percentage error. We just first find normal error, absolute error. That is delta A will have to calculate first. Then we'll move on to whatever they have asked. What is the relation between mass, volume, and density? Can anyone tell me? What is the formula for density?
Mass.
Volume upon mass.
Volume upon mass?
Mass upon volume.
Mass upon.
Yeah. You'll get ulta answers then. So density is mass upon volume. So what we have to find is the rho is what? Plus or minus delta. So first find this. Straight away, this is your M and this is your delta M. This is your V and this is your delta. So straight away, mass upon volume will calculate first. No, put this also, units also. Mass upon volume. Want to calculate, this is grams and this is volume, centimeter cube. So 2 grams upon centimeter cube. Your first part is done, that you got your rho. Now we have to find delta rho. So take the same formula again. Use. Now even if there is division, I told you, it will always be plus 1. Now substitute your values. Now calculate and tell me what you are getting for delta rho. Please avoid some silly mistakes. Anyone having doubts in such problems, please ask. Still, if you are not knowing what has been going on.
Miss 0.4.
Yes. This delta rho, you have to find. Rho is given to you as 2. This will be delta M 0.2 upon 2, 0.1 upon 1. So this anyways will cancel. So 2 will go up and 0.1 plus 0.1 will give me 0.2. So delta rho will give me 0.4. So now write it in the proper form. The rho is, what is it? 2 grams per centimeter cube plus or minus 0.4 grams per centimeter. Even worst case, if you forget the units, at least write a normal answer and keep. No, this is a normal density along with the error. Now percentage error has been asked. So what is the formula for any percentage error? It is nothing but relative error up into 100. Relative error is given to you as always delta this into 100. Now we have to find out density. That's why I used rho. If we had to find out volume, it would be delta V upon error upon actual into 100. So just substitute and calculate. So this is my rho and this is my delta rho. That's 0.4 and then upon 2. 0.2 into 100. 100 means multiplying means I have to move towards the right hand side. So 2 decimal places. Like this 20 it will become. Because there are 2 zeros, I have to move 2 places here. And then just put percentage because you are finding percentage error. Any doubts in this you can ask. Now slightly different type. Percentage error. Percentage error in mass of a cube is 1%. Same way percentage error in volume of a cube is 2%. Find percentage error in density. So whenever, just write a question, later I'll explain. The percentage error in mass has been given. Earlier what was happening, directly the mass and the volume they used to give. And then you had to calculate the density along with an actual value and your error, like the rho and delta. But now here, percentage error has been given. So let's see what does that percentage error of mass means. So whenever you are given any mass, how it will be given to you? M plus or minus delta. And just now we have seen percentage error will be what for mass? Always your error upon actual into 100. Anytime any unit has been given, how to find percentage error of that? Delta m upon m into 100. How we have just now done? Delta rho upon rho into 100. Same way, can anyone tell me what will be the formula for volume? What is the percentage error for volume?
Delta V upon B into 100.
Yes, that will be delta V upon V into. So given any this, we know how to find the percentage error. Now directly the percentage errors has been given. Same way, what has been asked? To find percentage error in density. So what we need to find, that is delta rho upon rho into 100 is how much? So this is what we have to find. So whenever all the data has been given to you in percentage error form, what you have to basically do is just take the normal formula, density is mass upon volume. Now, are the actual lengths given to you? Like how we were doing in the previous problem, we were doing 2 steps. First we have to find rho and then we have to find delta rho. But here normal rows also we don't know what is M, we don't know what is V, we don't know. We directly know their errors only. Whenever it is given in error form, directly go for the second step, means the splitting step. So rho will be what? Delta rho upon rho. This will be delta M upon M. Division means it will be plus. So directly I'm jumping to the second step because the first step, no data has been given. Now if you compare with this data, which is a number which is missing here everywhere, that is 100. Everywhere actually there should have been 100 if you compare. For this one also there should be 100. So this one also there should have been 100 and this. So I want everywhere 100. So what I will be doing is multiply both sides by 100. So I'll convert them all into percentage form. So whenever I'm multiplying both the sides by 100 means all the terms this side will get multiplied by 100. All the terms will get multiplied by 100. It's like multiplying together by 100 and then 100 will go and get multiplied to both the terms. So that step anyway no need to show. All the terms directly multiply by 100. So what is this? Nothing but the percentage error in density. This is a percentage error in mass. This is a percentage error in volume. And straight away percentage error has been given to you. What is the value of this? 1%. And what is the value of this? 2%. So directly substitute. Both the sides I multiplied by 100 and converted them in percentage error form. Now just have to substitute. The percentage error in density is equals to, what is this value? 1%. What is this value? 2%. So total is 3%. 3% is my answer. Anyone who has not understood can ask. If you have understood this, then try the second one. Just giving you in shortcut form, percentage error in A and B are 2% and 3%. Okay, this is for A and the second one is for B. Find percentage error in P. Now no need to write that extra data first. That's how I told you, know what is delta P. That was only for explanation part. You can directly take the formula, start splitting it. Directly start with the second step. Delta P upon P is equals to whatever you should be getting. Powers means always write them at the side. Square will become 2 as a coefficient. Cube will become 3. L1, can you tell me what will be the next step? Yeah. L1, what I'll write it as? You're there? Can it already? L1, I hope I'm pronouncing it right. Wait, wait. Okay, Ansley, can you tell me?
Yes, delta P upon P is into 100 is equal to delta A square.
No, first one you don't multiply 100. First tell me the basic one.
Delta A upon A plus delta B upon B.
And where the 2 and 3 went flying?
What square?
Yeah. They went for picnic. Yeah, no?
Yes,
Always put
teacher.
down with the. And now multiply both the sides by 100. Multiply both the sides by 100. This will be by 100. So delta P upon P into 100, this is equals to everything will get multiplied by 100. So now this value is percentage error in P. This is percentage error in A. And this fellow is percentage error in B. So 2 is there at the side. So this will be 2 into 2% plus 3 into total. 2 into this will give you 4% plus 9%. The total will become 13%. That's the answer. The last one on this step. This is for a cube, huh? Percentage error in mass equals to 2%. Percentage error in length is 1%. Find percentage error in density. Now here the slightly different because density formula is mass upon volume, but if you see length has been given. The percent density we know is mass upon volume, but is V given to us to calculate? No, so we have to first see what has been given. Mass has been given, this is also there. This volume we'll have to check now. What has been given? A cube. Volume is always length into breadth into height of any cuboid. Cuboid means all different sides. But now for cube, everything is L only. Height also, breadth also, length also. Because all the sides are equal for length. So it will be length into length into length. And if breadth was given here, no, as breadth, it would be B into B into B. If height was given, we have to write it as H and H. Whatever has been given now, L length has been given, that's why I have to write everything in terms of length. So instead of V, we will use here now L cube because L has been given. Because we use V, we don't know what is percentage error in volume. And now apply the second step and start splitting. Kale, are there?
Yes, miss.
I'm pronouncing it right now, your name?
Yes, yes.
Yeah. So what will be the next step?
Step
Delta rho, then delta rho upon
divide by rho.
then
Divide by rho
then
is equal to delta m
Hmm.
upon m
then
plus delta L, 3 delta L upon L.
yes, very good. Now just multiply on both the sides by 100 and then put the value. So this will be how much total directly given to you as 2% plus 3 times into 1%. 3 into 1 will give me 3%. So total is 5%. So this is how you have to calculate your errors. Next topic is significant figures. If you go to read your textbook, it will be very confusing. Okay, so don't break your head on that. So whatever has been taught, you just focus here. I'll make sure everything has been covered. Okay, any topic is left, any students are sent, I'll do it finish by next class. That conversion and all from one unit to another. But I make sure whatever has been done in your college notebook, that will be covered. So you all need to cooperate. Anything different other than what I am teaching has been taught, you can always send me the photos. But if you go start reading your textbook, you will be lost. Must have seen also some of them. All the terms and all are complicated. Just try to understand whatever I teach you now. Just a significant. This is just the definition wise, nothing to break your head or something, and just reliable digit plus the first uncertain so what is a significant figure. So as for the definition wise, it is nothing but it's like all reliable digits plus first uncertain digit. What it means, I'll directly help explain you with the help of an example. So just write this. So suppose if I say Priya's school is 24.567 meters away. So there will be some decimal points involved, something like this. So always there will be one uncertain digit. Okay, the first one. From always you move from this side. So the first fellow is always called as the uncertain digit. So 7 is called as a uncertain digit, and the remaining 2, 4 separately. Okay, we'll read them as separate, not as 24 and all. 2, 4. This is digit 1, 2, 3, 4, 5 like that. 2, 4, 5, 6. Okay, called as reliable digit. So we have to add like both of them. So total how many significant digits? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 4 reliable plus 1 uncertain. So total 4 plus 1 will give me 5 significant figures. So always the first fellow from the side is called as the uncertain, and the remaining are called as the reliable one. Same way, suppose if you have so 2 is your uncertain, okay, and these are called reliable. So total 3 significant figures. These are your examples. So now there are certain rules for significant figures which I'll give you all now. This is just from the definition point of view, you should be knowing. That's it. Now the rules, definitely you have to understand. Simple there. First rule, all non-zero digits are significant. Just write this, I'll explain what it means. All non-zero digits are significant. Non-zero means other than zero. Any number other than zero are called as non-zero digits. This is zero, is a zero digit. The rest all 1, 2, 3, 4, 5, 6, 7, 8, 9. These are non-zero. Any number framed by these digits is called as a non-zero, and that will have those many significant numbers. For example, I'll give you I want to know how many significant numbers are there. So as long as there is no zero involved in there, directly you can count all the numbers, all the digits. 1, 2, 3, 4, 5. How many significant figures? 5 significant figures. Can anyone tell me how many significant figures here?
5 significant.
Who got 6? 5 only. 1, 2, 3, 4, 5. Doesn't matter where the decimal point is. That's not my botheration. Just have to see whether there is 0 or not and just count the number of digits. Just put. That would be 5. Yeah?
2.
Yes. So then even if there's no decimal point.
3.
3.
Okay. So this is the first rule. Second one. All zeros. If there are zeros, then what to do? The zeros should be between two non-zero digits. All the zeros between two non-zero digits are significant. Suppose if there is any zero, but it should be always between, it should be both the sides, left hand side also, right hand side also, it should be surrounded by a non-zero number. This number should be present Okay, if he's left out alone somewhere, then there are more rules to check. Okay, total there'll be 5 rules. But when they can be considered significant, if it is between two this. Example, now I want to check how many significant numbers are there. Now there is a 0, but now the 0 is between, this is a non-zero, this is also non-zero. So definitely I can consider him as a significant figure now. I can count him under that category of significant, because all the zeros, if they are between non-zero, are to be considered significant. So total 3 significant figures. 1, 2, can anyone tell me how many significant
4.
figures? 4. So doesn't matter how many zeros are there. Even if there were 3 of them, then it would be 5. As long as all the zeros are there between non-zero numbers. So both the sides, they should be packed by a non-zero. They should not be left open. So here 4 significant figures. And
5.
yes, 5.
5.
Yes, 5. Because again, they are surrounded by non-zero. Even this one is surrounded and this one. 5 significant figures. So this is about second rule. Rule 3. Ending 0 means, suppose if you have an ending 0. So there are 2 conditions for that. Okay, at the end, suppose if you have a 0, it should be, the first condition should be after decimal point, and the second condition is at the end. It should be not anywhere in the middle. Okay, and mean this, if it is at the end, then the condition is it should be after the decimal point only. I'll give you examples. Here you can consider that 0 as significant because both the conditions have been satisfied. It is at the end and it is after the decimal point. After means you have to always read from this side. So always after the decimal point it is there. Okay, so both the conditions. So this is at the end plus after decimal. So that's why total 3 significant figures. All the 3 are to be considered. Another one.
Five.
Yes. They are all towards the end now. Because there is no other number. So in between, there's nothing more is left. So what it will be, all of them are after the decimal point. So you have to consider all of them. So this will be 5. So they're all there towards the end of the number. There should not be any non-zero. So if all the zeros are towards the end, yes, correct. It has to be considered. Same way even this way. So here it would be these two are to be considered because they're after the decimal point and towards the end. So 4. What about this? How many significant numbers? Can anyone tell me? Yes, very good. Here we have to take only 2. We cannot take this because this is there at the end, but this decimal point condition is not been satisfied. It's not after a decimal point. So in this case, only this two significant figures because 0 is not after decimal. So even though it is at the end, but it is not after the decimal point. So that's why that 0 is not to be considered under significant figures. So only 42 will be that 4 and 2. We have two significant figures. So this was rule 3. Initial zeros are insignificant, are not to be considered significant. And suppose if they are not towards the end, what is to be done? Over here, initial zeros are all insignificant. So only these two. Even though they are after the decimal point, but they are not towards the end. So initial zeros, whichever are there, which are not towards the end, are to be considered insignificant. Initial means in front first. Any doubt in this? Can ask her. One more example. Let's see. Anyone can tell me how many significant numbers? Yes. Yes.
4.
Yes. Very good. So these are not to be considered because they are initial. This fellow is correct because he is between the two non-zero numbers, and this is towards the end and after the decimal point. So these are considered. So total will be 4. One can write this was between two non-zero and after decimal point. That's why I'm considering this. And these are initial ones. So that they have to be considered insignificant. The last rule, powers of 10 are insignificant. Example, how many significant figures to be considered here? Only these two. This is to be considered insignificant. Any powers of 10 will be not considered. Only 2 significant figures. Just one significant figure. This is to be ignored. And just for a note, constants like pi and all, you know that 3.14 something, it will just go on. Okay, the value of pi will just go on. The constants like pi and all, they are usually say that they have infinite significant figures because it's non-ending. Normally they consider it to be infinite because the value goes very big. So now, given based on all the 5 rules, first answer, can anyone tell me?
2.
Yes,
2.
yes, 2. Because initial ones not to be considered. This and this. It's there at the end after the decimal point. Then second one, simple one it is. All are non-zero. Yeah, all non-zero, so straight away 4. Here,
3.
3.
yes, 3. This is to be ignored. Fourth one,
3.
3. This is ignored, this is ignored. Yeah,
4.
4.
4.
One, Yeah, sixth one.
5.
Yes. Then seventh.
4.
Yeah.
7.
Not 7. Just see.
6,
6. 1, 2, 3, 4, 5, 6. This is not to be considered. No decimal point. It's not after the decimal point. So this 0 towards the end cannot be considered. Only here. If there was a decimal point somewhere here, then it would be. So here 6 is your answer. And then here
2.
2. Again only this 2. This is also not to be considered because there is no decimal point. Okay. So this is how we have to check how many significant numbers are there. Based on all the 5 rules, this is how we need to check. Any doubts in this? Anyone can ask. Next is how to round off. Rounding off. This is also very simple one. Now I'll just start with the examples, and as it is, I'll just explain you the rules. Okay. So suppose first question, if it is there, round off 2.42 into 2 significant numbers. I'm told I want to round off the number to 2 significant numbers. So first we have to check how many significant numbers are there. So definitely now you know that there are 3 significant numbers, and we have to always start from this side. 1, 2, and now up till how much we want? Till this point. At this point. So this fellow is called as I told you, the end fellow is always called a uncertain. The uncertain figure is to be dropped off, or whatever it may be. I don't want this. This word we have come across in the textbook and all. Uncertain, to be dropped off and all. No need to by heart as such, just try to understand. Now I want only this. Simply I cannot remove and throw him out. Okay, just because I'm told it. So there are certain rules we have need to check. So this is to be removed off because I want up till here. So we have to check. Okay, so the third one is called, the third digit is right now called as the uncertain digit. The last ending one. So I'll use it as third digit only right now. So check. If less than 5, okay, if less than 5, add 0 to this previous number. Or what it means? Or second digit remains same. Adding 0 to the second digit means it will remain same. If this number is less than, always will have a scale now like this. Middle will be 5. If it's falling in this category, and come up till 9. Okay, if this side it is there, you have to add plus 0. If it's any number is there, you have to add plus 1. If the number is more than 5, you have to add +1 to the previous one. But now the number is less than 5, so add 0 to this, or basically it means keep it as 4 only. Adding 0 to 4 means it remains 4. So my answer, now check, 2 is definitely less than 5, so I'll add, it will remain like this one. So I have added 0 to it. So that's why my answer is 2.4. Any doubts in this? No. Second one, suppose no, definitely same for the same round off to 2 digits only. So I want only this much. So this is my third digit. Third digit is how much? So greater than 5. If the number is greater than 5, add to the previous number. Previous digit. So what is going to happen? This will be dropped off. This will go. So this one's value became +1. Why? Because he is greater than 5. Answer is 2.5. Add +1 to the previous digit. Any doubts in this? You can ask. Now quickly tell me what will be the answer of this.
2.4 and 2.5.
How 2.4? Yes, this check this now. Now I want to round off to 2 digits only. 4 is less than 5. So I have to add +0 to this. Less than 5 means it will, the answer will be 2.3. No change if the number is less than 5. Now this fellow is 6 is greater than 5. So that's why I have to add +1. If my answer will be 2.5. Clear now? So someone had told me no 2.4 answer. You got your doubt cleared?
Yes, teacher.
Next is okay, that I'll start next time because it will take time. There are some rules in that. Suppose if there is 5, then what is to be done? This was what we checked when it is greater than 5 or less than 5. But when there is exactly 5, there are more rules. Okay, just 2 more rules. Next class I'll be anyways finishing with the chapter. We'll stop here.